Welcome to today's webinar, National Study to Quantify the Life-Extending Benefit of Pavement Preservation, a MnROAD and NCAT partnership. My name is Jason Nelson, and I will be moderating the session. You may ask questions during the session using the question module on the GoToWebinar control panel or by email at nelsoja@auburn.edu. We will answer as many of these questions as time allows at the end of the session. Our content today will consist of a message from our keynote speaker, an introduction to MnROAD and the NCAT pavement test track, an update on our pavement preservation study on Lee Road 159, the continuation expansion of that research into the 2015 research cycle, the MnROAD NCAT partnership, how you can get involved, and finally a Q&A session. With that, I will introduce our keynote speaker, Mark McConnell. Mark is the Deputy Executive Director and Chief Engineer for the Mississippi DOT, as well as the current chair of the AASHTO Subcommittee on Maintenance. Mark?
Good morning, everybody. It's a pleasure to be on this webinar, and I appreciate everybody's attention to this extremely important topic. For those of you who don't know me, I started with Mississippi DOT back in 1988, and I started in construction, but then moved into the maintenance operations side. Spent a good part of 15 years in the maintenance side, then became assistant chief of our operations, which is maintenance, construction, and traffic, and then became chief engineer about 3 years ago, and so now I also have pre-construction. But having come from the maintenance side of the world, I understand the battles that all DOTs have in maintaining their pavements and their bridges. And so pavement preservation is critical to the nation and how our pavements are maintained. I guess because of my background in maintenance, I was asked last year to become the chairman of the Subcommittee on Maintenance, which is it's a big honor for me. Coming from the subcommittee back when I was in the maintenance area, I got to know Carlos Braceras very well, and his leadership has been exemplary, and I just hope I can maintain that. But I also was honored because it's a true need in our nation, and we've built out a lot of our new construction, our 4-lane highways, and it's critical that we now are able to maintain them in the most economical way we can. One of the things in the subcommittee on maintenance is that we have a technical working group on pavements, and that's the letter in front of you is a letter that I wrote to for AASHTO to go out to all the state DOTs to ask for their support in this research on pavement preservation. Pavement preservation is critical. If we had all the money in the world, we could maintain our pavements in perfect condition, and we wouldn't have any problem with trucks and all the variables, winter maintenance, which, by the way, I always thought I was living in the south of Mississippi, but it's 14 degrees this morning, and we don't quite know how to handle that kind of cold, so y'all can have that up north. For instance, in Mississippi, we have determined through our pavement management system that right now we need about $1 billion, that's with a B, to get all of our pavements into what we consider an acceptable manner, and $400 million in addition to what we already get to continue to maintain it in that situation. Right now we currently are allocated about $85 million for overlays and pavement preservation and $60 million on our interstate highways. So you can see, and I know this is not just Mississippi, we're a small state, small rural state, so it's even magnified more in the bigger states, but in Mississippi it's a big problem because it's such a small percentage of what we actually need. And we hope that we've made inroads in trying to get more funding, not only for overlays and other type pavement needs, but also for pavement preservation. And we've made inroads with our state legislature, and hopefully on the national level we'll be able to get more funding as well. But one of the things that's so critical to pavement preservation and to pavements is that the treatments that we use have got to be successful. We've had some situations in Mississippi where we thought we had a good product, and it probably was a good product, but when it was put down, it wasn't put down correctly, and because of that, you know, that makes that product not look so good going forward, and it makes it harder to convince folks to put it down again. So this research is very important, that we know that the pavement treatments that we're putting down are going to work, and that they last, and that they do extend the pavements. I think all of our DOTs now have pretty robust pavement management systems, and they do provide information that allows us to make good decisions. For instance, here in Mississippi, we have decision trees on, you know, which type treatment should be used and at what time, but we don't have the way to connect the dots and know that that treatment is going to last the way we think it's going to last. In 2012, we participated in the pooled fund in Lee County, Alabama, to do a bunch of different treatments, and it was in Alabama, so it's a warm climate, and it's going to be very beneficial to Mississippi because that's the climate we're in. That was done in 2012, and the research is coming to an end, and it's really important that we support it going forward, so we really can tell, you know, how it's going to last. Is it going to extend the pavement? How is it going to compare to other treatments, or even not doing anything? So it's really important that we go forward with that and support that research going forward. But the other thing is you know, the South is not the only place that needs pavement preservation, and the northern climates need it as well. And, you know, like I said, it's 14 degrees here in Mississippi, and it rains just about every 3 days, and then it freezes and thaws and in this particular time of the year. So we need to know how pavement preservation is going to work in the winter as well. So now there's a partnering effort with MnROAD in Minnesota, and so that's going to be really important that we all support them doing a similar type research in Minnesota that we did in Alabama. And in addition to that research, part of this effort is to see how our asphalt pavements, or how we can better understand cracking in our asphalt pavements, for instance, as it relates to the amount of wrap in our mix, or additives, or warm versus hot mixes, and that type of stuff. It's something that we've needed, and that's another piece of this research that's going to be really important. So I didn't want to take up a lot of time because I know there's a lot of important stuff coming up in this webinar, but I did want to thank everybody for allowing me to participate, and I appreciate the work of NCAT and MnROAD, and I just hope that everybody is supportive of this research, and if I can help in any way going forward, I'll be glad to. Thanks very much.
Thanks, Mark. Our next presenter is Ben Worrell, MnROAD Operations Engineer at Minnesota DOT.
Yeah, thank you for the introduction. Also, thank you again, Mark, for your support and your committee's endorsement for this partnership. I want to quickly go through some of the benefits and how MnROAD is laid out. MnROAD, again, is owned and operated by Minnesota DOT. We've had 20 years of long-term customer service. Some of our customers have included Minnesota Department of Transportation, the Minnesota Local Road Research Board, which is cities and counties of Minnesota. We've done a lot of pooled funds with states and industry.
Thanks again for listening.
Excuse me? Jason, are you hearing me?
Yeah, you're fine.
Okay. We work with Sharp 2 and FHWA on national events, different types of pavement projects throughout the years. And we've gone through our first 2 phases of research and now are finishing up our second phase that is finishing up in 2016. Currently we're looking at our 3rd phase and looking at becoming more of a national facility, use national different pavement questions that we have. MnROAD is an accelerated pavement testing facility located just northwest of Minneapolis, St. Paul. We built the sections along existing Interstate I-94. We built a mainline 3.5-mile stretch of roadway alongside there that we're able to move traffic back and forth as we need to. We typically move the traffic over 3 days a month to do different monitoring on that test section. We also have a controlled access low-volume road that the Local Road Research Board primarily funded to look at city and county designs. This has 2 one-mile stretches in this 2.5-mile loop. Some of the benefits over the years that we've seen for our phase 1 related to developing models for predicting seasonal load limits, when to put on and take off spring restrictions and winter overloads. We've worked a lot with improving our designs that we use here in Minnesota and the northern states related to flexible and rigid updates. We found that environment drives up pavement performance a lot more than we originally thought, and our current designs are much too conservative typically. We also found that sealing pavements and sealing shoulder joints can improve pavement performance quite a bit. And these benefits saved us annually $33 million a year we're figuring out here in Minnesota. Phase 2, we've been kind of looking at the last 2 years, and we're just finishing up some of that research. But we've done a lot of work relating to developing a performance test for low temperature cracking. We'll talk a little bit more about this later. But the idea of testing a material before it's placed in the road to ensure its performance. We've also seen the power of using full depth reclamation on our roadways that are heavily cracked to remove that cracking and to provide a good smooth surface. We've worked with the industry and different groups on asphalt modification and the performance of those types of binders in our asphalt pavements. But we've also worked with concrete and looking at improving concrete overlay designs, use of recycled materials in concrete, including fibers, and how to diamond grind in the most effective manner. We've done a lot of work with coming up with innovative diamond grinding and along with concrete repairs. We also found that unbound materials, we've done quite a few research on that related to the importance of drainage and coming up with a stable but drainable type of base, and how the use of recycled materials impact performance and how those can be used most effectively in our roadways through the seasons that we go through. And we'll talk a little bit more about pavement preservation a little bit later in this presentation. Some of the future research that we're looking for our 3rd phase when we come to it in 2017 is we'll be utilizing existing mainline, old westbound concrete sections. We could do a lot of different overlays and things like that related to reflective cracking, and also utilizing the low volume road. We'll be looking at concrete and asphalt materials. Pavement preservation and rehabilitation will probably be the primary focus, along with some new construction. And again, the strength of MnROAD is the same as the strength with NCAT in a lot of ways. Is we have a controlled real-life experiment. It's very little impact and risk to the public. You know, we've been going on for quite a few years, since 1994. We've had long-term local support and experienced MnDOT staff that we've developed over the years to handle all the instrumentation, monitoring, and working with the different research studies that we work on. Again, we're coming up with accelerated findings and trying to get those implemented as fast as we can to get the benefits for our society. We've had local and national efforts, and we'll be kind of coming up with, going through some of these coming up in start of February. We have a workshop here in Minnesota at the University of Minnesota, followed by an annual pavement conference. So that's kind of our basic introduction to MnROAD, and now Randy can kind of go into NCAT and their facility.
Good afternoon. This is Randy West. I'm the Director of the National Center for Asphalt Technology. Unfortunately, my part of this webinar was pre-recorded. I wish that I could join you live, but I have another meeting that was also scheduled for today. First of all, I want to say thank you for participating in this webinar. At NCAT, we are very pleased to be teaming up with MnROAD to address two very important national needs that my colleagues will be sharing with you. I would also like to thank Mark McConnell for his leadership and the support that the AASHTO Subcommittee on Maintenance has given for the research plan that MnROAD and NCAT has put together. Since its beginning in 1986, NCAT's mission has been to conduct practical research and effective outreach to improve asphalt pavements. Today, our team of 45 research engineers and support staff is still dedicated to working with our sponsors to make roads safer, smoother, quieter, and longer lasting. By and large, most of our research at NCAT is funded by state DOTs, either through direct projects or pooled fund projects. State DOTs also sponsor the competitive National Cooperative Highway Research Program. These are NCHRP project reports that NCAT has completed in the last few years. We also compete for projects funded by the National Asphalt Pavement Association and work on projects funded directly by the private sector. We also have a competitively awarded contract with the Federal Highway Administration to support technology deployment. The centerpiece of our research program at NCAT is the pavement test track. The test track began operation in 2000. It is a 1.7-mile oval with 46 test sections. The track operates in 3-year research cycles. Individual test sections are sponsored by DOTs or industry sponsors. In the past 3 cycles, we have had groups of sponsors to work together to sponsor common experimental objectives that involve multiple test sections. The cost of each test section is based on 3 categories. The first category is a surface layer experiment. The second category is a full-depth structural study with stress-strain instrumentation. And the third category is simply continuing traffic on a previously built test section. We apply traffic loading with 5 trucks pulling triple trailers that run 2 8-hour shifts per day, 5 days a week. The axle loads are the maximum axle loads allowed on the interstate system. In each 3-year cycle, we apply 10 million 18-kip equivalent single axle loads. In the first few cycles of research on the track, the focus was on refining many of the superpaved specifications, such as proving fine-graded mixes work just as well as coarse-graded mixes, and demonstrating the benefit of polymer-modified asphalts and the benefits of SMA mixes. Research also showed that we should reduce the design compactive effort used in superpaved mix designs. Sponsors have also used the test sections to evaluate some of their aggregate specifications and then took the findings from those and put those into practice right away, often leading to significant savings in aggregate cost in all or part of the state. Another very practical research was to find the limit for lab compacted air voids, a fairly universal pay item for asphalt construction. This research helped set the limit at which mixes should be removed and replaced. In the last few cycles, the emphasis has been on the durability of pavements containing recycled materials such as RAP, recycled asphalt shingles, and ground tire rubber. We're figuring out how to optimize the mixes and the pavement structures to provide longer life and lower cost. We've also evaluated a variety of other mix additives to understand their added value in a real-world pavement environment. And we have also combined all of those materials with warm mix asphalt technologies in test sections. The performance of each test section is very closely monitored for all forms of pavement distress, for structural health, and for friction. Some sections are designed to fail within 1 or 2 research cycles so that we can model the full life cycle of the materials and the structures. Now, since the track is a closed facility, pavement failures do not cause any public safety issues or create political jeopardy. The materials used in each test section are tested using the latest technology so that we can begin to establish stronger relationships between lab tests and field performance. This will enable us to better improve the specifications and the performance of tomorrow's asphalt pavement. Thanks again for listening to this webinar. We do hope that you will be interested in partnering with MnROAD and NCAT to find implementable solutions to today's pavement needs.
Well, thanks, Randy. This is Buzz Powell, and I'm an assistant director at NCAT and the manager of the NCAT pavement test track. If you look at an accepted definition of pavement preservation, the big unknown for state DOTs is pavement life extension. As Mark mentioned in his keynote speaking at the beginning of this webinar, many DOTs have really well-designed and well-thought-out decision trees where they can take pavement management data and end up with a rational selection of preservation alternatives. But the issue of extending pavement life is really the big unknown for them, because references will provide broad ranges of expected performance for different preservation alternatives. Well, in order to address this need that DOTs have, beginning in 2012, the 2012 research cycle, for the first time at the NCAT pavement test track, we built test sections off the track over on Minroad 159. This is a very low ADT roadway, a very high percentage of trucks. It was a 14-year-old pavement, about 5.5 inches thick. It had really diverse pavement condition because the road had evolved over time from a one-lane dirt road, widened and overlaid into a two-lane road. So between the wheel paths, there's significant differences in pavement condition. And then you have empty trucks generally going into the quarry and the asphalt plant on this dead-end road, and generally loaded trucks that are leaving. And we have a data sharing agreement with the quarry and the asphalt plant, so that in comparison to the test track where we have precisely control our trucking and our fleet operations, we're just exposed to commercial trucking on this road, but we have a very accurate record of unloaded truck weights going in and loaded truck weights coming out. So what we've done on this half-mile section of roadway is split it up into 25 test sections, as you can see from this aerial shot here, and in 100-foot sections that are 2 lanes wide, we have an array of pavement preservation test sections that were added to the track research plan. This experiment was funded by 7 state DOTs in partnership with FP2, and it was supported by the Lee County Commission because this is an open county road. We appreciate that very much. If you look at the 25 sections, 2 of them were set aside as control sections, and we used 2 controls because they had significantly different levels of distress, and we felt like that was important to capture the full range of performance. But we have fog seals and chip seals, microsurfacing, different types of cape seals, and then thin overlays that are laid out in this 25 test section experiment. Now, every week and then monthly and quarterly, going all the way back to pre-treatment condition of these test sections, we measure rutting and roughness and texture. We measure surface friction on a monthly basis, subgrade moisture contents on a monthly basis, which I'll get back to here later in my part of the presentation. We do falling weight deflectometer testing on a regular basis so we can capture seasonal stiffness changes. We've done selective ground penetration radar testing, and then we do visual and video-based crack mapping on Lee Road 159 like we do on the test track. So this is a baseline crack map for one of our treated test sections, and this is shown in red because this was the cracking that was in place before the treatment was installed, and this was back in July of 2012. To give you a sense of orientation, trucks are driving into the quarry as they go from left to right in this section, and this is actually half a section because test sections out there, as I said, are 2 lanes wide. So this is the inbound part of that section. And you can see the inside and the outside wheel pass and how the pretreatment distresses relate to those orientations. So we applied the treatments in the summer of 2012, and that took our crack map back to no cracking. We got our first crack in this particular section the next summer in July, and I'm just going to very quickly progress through time in this section and show you how the cracking that we measured in this section evolved over time. This is the second summer. And then finally, October of 2014. And as you'll learn a little bit later on, we're hosting a conference in March where we'll publish a synthesis report on performance on the track and on LeRoad 159 for the 2012 research cycle. And the cutoff point for the data on LeRoad 159 is October of 2014, but we're continuing to collect data out there on a weekly and a monthly basis. So this is in that sense, is the terminal crack map for data that will be reported at the track conference. And I'm going to overlay on top of this the pretreatment crack map, so you can see how the existing cracks out there relate to the pretreatment cracks in this section. And what we've done, even though we have 25 test sections, you have to visualize that each individual test section has been subdivided into 40 subsections. So we're discretely mapping all the distresses, the roughness, the rutting, the texture, the cracking, in terms of these 5-foot by 10-foot subsections. So there are 20 subsections in the half lane, 40 in the complete lane, and you can see how the cracking is distributed throughout. And this was important in the design of the experiment because we really needed a diverse set of pretreatment pavement conditions so we could capture the full range of treatment performance. So if you look at this overlay, first thing we need to do is discount these two cells because that actually is where a water line, a water main runs underneath the road. So that cracking really is not representative of the potential of this treatment. And then if you look at the rest of the subsections, I've highlighted in green here the sections that you could argue are generally in really good condition, and yellow the ones that are kind of in a medium condition, and then in red finally the most serious distresses, the most serious cracking that we have mapped out there. So if you move to kind of this conceptual pavement life cycle curve, what that means is we've got in each individual test section we have surface map, a group of these 5-foot by 10-foot subsections that fall into the prevention and the rehabilitation and the reconstruction zone of the pavement life cycle curve. So we have a good distribution of points in our test sections that we have installed out there. And if we look at one of the 5-foot by 10-foot subsections that I'll highlight in yellow, when the treatment was applied, we reset that data point to a high level. We monitor the trucking that is occurring out there on a regular basis, and as we do our weekly and our monthly testing, we watch pavement condition change. And what we're really looking for here is to identify the life extending benefit of pavement preservation for each of the 5-foot by 10-foot subsections within the treated test sections. And we also have the two control sections in place that we can monitor and look at their rate of change as a function of the exact same traffic over time. And then we can predict what would have happened in that section had the treatment not been applied, which then gives us a condition improving benefit. So those are the two key pieces of information. You need the life extending benefit for the decision tree to select the best life cycle cost alternative for preservation, and then you need the condition improving benefit so that you can take the diminishing resources that Mark mentioned at the beginning of the webinar and you can do build, no build cost scenarios for programming decisions. So the objective, the deliverable of this study for each of the treatments in place and the treatment combinations that we have in place, because there are quite a few combinations of treatments, for example, Cape seals and then HMA Cape seals. Each of the test sections will produce an independent life extending benefit curve, and these are points that'll be generated for each of the 5-foot by 10-foot subsections, individual curve for each treatment. And what you see then is when you use a treatment on a pavement that's in bad condition, it doesn't take much traffic to return to pre-treatment. But then as you improve condition, you get more time, more traffic, and longer life cycle performance. So this is the deliverable that will be produced from this experiment. Now, also important that we wanted to mention is we have installed moisture tubes in the middle of each section on Lee Road 159. As you can see in this picture, the tube is installed in the middle of the section in the X direction and in the Y direction. So it's in between the wheel paths. And what this is a seal tube that has a cap that we screw off, and then we drop a nuclear moisture probe down in it, and we can do monthly moisture tests. What you see in this graph is that in the first winter, in the first wet season, there was a significant difference between the treated test sections and the control sections. And then what you also see over time is that in the second winter, for some of the sections, that improvement, it sort of panned out, and it wasn't so significant. And that's because cracking is occurring and more moisture is getting into the subgrade. So these measurements are important because we can see what's happening on the surface of the pavement. FWD testing and moisture testing is telling us what's happening inside the pavement as cracking develops on these test sections. So very quickly to summarize what we've seen on Lee Road 159, crack sealing appears to be beneficial in all cases, having a positive impact on crack development. There are differences between routing and sealing and blowing and banding. Scrub seals appear to exhibit the crack seal benefit and the chip seal benefit, which is what you hear about crub seals. Preservation treatments do reduce subgrade moisture content, but in sections where cracking develops, when cracking does develop, as you might imagine, that tends to taper off. Microsurface has been proven to be very durable. We have some microsurface that we've also done on the test track. There are some comparison sections on the track that I don't have time to get into within this presentation. We are developing life-extending benefit curves. It's very exciting to go through the data to prepare for the synthesis report for the track conference and see how the data is behaving as we expected it to. And we will be publishing those findings at the 2015 track conference. We would invite everybody to attend this conference. It's March the 3rd through the 5th, so it's just right around the corner. It'll be a 2.5-day event with a focus on the track and Lee Road 159 with tours of both facilities. And these track conferences, we host them at the end of every 3-year research cycle. They're very important in our transition, our turning point between the last research cycle and the next research cycle. So there'll be discussion there of the experiment that we'll build in 2015. We will continue monitoring the sections on the track and on Lee Road 159, the pavement preservation sections, and that's so that we can capture the life-extending benefit curves. We don't have that data point until we return to pretreatment condition. And I focused on cracking for this presentation, but obviously there are many other parameters that we're measuring on a weekly basis that are part of that. The MnROAD partnership, there'll be a focus on the MnROAD partnership in the conference because it's a centerpiece of what we're doing in the 2015 research cycle. And then also down here, we'll build new sections on a higher ADT roadway. So showing you where the track is here on this aerial photograph. There's Lee Road 253, and about 4.5 miles down the road on US 280, you get to Lee Road 391, which is where you would turn off to drive down to the test track. So this is about 3 miles east of the track. They're very, very convenient for mobilization and material storage purposes. This is a 17,000 ADT roadway. It's about 9 years old. The westbound outside lane, this is a divided 4-lane, so we're interested in the newer part of it that had a really balanced cut and fill, very level and very straight, about 4.5 miles. We'll do 1/10 of a mile test sections out here, so it'll be data collection that can be interpreted in a way that is very similar to how DOTs interpret their network level pavement condition surveys, but we will still discretely monitor subsections in these sections just like we've done over on Lee Road 159. Our expectation is that we'll repeat the treatments on 159. The final experiment will be designed by the state DOTs that get on board to fund the experiment, and it'll be done through by consensus, but our is that we'll repeat the treatments on Lee Road 159, and we're very excited to be adding recycle mixes. So our expectation is that we'll do some central plant recycling and in-place recycling, both using foam and emulsion, hopefully do some hot in-place recycling as well, and then we'll overlay those with high binder replacement thin overlays. So in that sense, it has a really good connection to the cracking group experiment that will also be a big part of the 2015 research cycle, because we've got to make sure that these thin overlays that have a lot of reclaimed and recycled binder in them have a really good level of cracking resistance to give us good performance. This section of US 280 is about 7 3/4 inches of asphalt pavement on 10 inches of aggregate base. Here's a shot of the road, and you can see the eastbound lanes are the original 2 lanes of US 280, and they didn't do as good a job balancing and cutting the fill, so it's kind of a roller coaster ride over there. But the westbound lanes are flat and straight. And looking at the outside lanes, the truck lanes on this roadway, there is a nice distribution pavement surface there of cracking, and there's a close-up view of the cracking in the outside wheel path. So at this point, I'm going to hand back off to Ben Worrell at Minnesota.
Thanks, Buzz. Again, we're going to talk a little bit about MnROAD and some of the works that we've done in the past related to pavement preservation. We've done quite a bit of work related to Minimac and microsurfacing. It's basically related to rutting and ride. We found that the more you work on these types of repairs, the longer life, the better, the smoother the road can be. We've also found that the flexible microsurfacing here in the north, that we found that even roads with in poor condition can last longer than we expected. So it is an effective treatment for our roadways, and we like to look at this even more. You can kind of see the rutting and the fills that we did, looking at rut depth over dates and how microsurfacing and using the Minimac has improved our system. We're also working with thin overlays. We'll talk a little bit about this later related to the cracking experiment. I'll mention that. Along with concrete repairs, we've done quite a few full depth and partial depth repairs on our concrete roadways. As you can see a picture right there. We've done some work with the Aging Pooled Fund study. The Asphalt Institute is just finishing up a study looking at when is the proper time related to the binder and its aging, should a treatment be placed. And it's finding that you need to put the treatment right away to prevent that aging of the asphalt. And this is not performance, but it is one indicator saying that doing pavement preservation is beneficial. We also done some work on chip seals on our low-volume road, but we also done some high-speed chip seals in 2014 with the R26 group that came out here this summer. Tom Wood kind of helped pull this together. He did a really nice video on how this is done in the application of using chip seals. But with this, we're trying to look at what is high speed, when can it be used. Each different agency looks at volume, what is high volume. We're kind of be looking at that and seeing that we can probably use these types of applications on higher speed roadways and higher volume roadways such as interstates. Again, all these different types of service work that we've done in the past I think will fit really well into kind of the analysis method that NCAT's developed to develop these different types of curves, and the information we've done in the past can be utilized. This partnership that we developed with NCAT, we've worked with them in the past for quite a bit, but nothing's been formal. It's all been informal in the past. But in June of 2014, this summer, NCAT came up to MnROAD and we started the discussion. We followed that up with a meeting down at NCAT where a number of us from Minnesota went down there, started talking about this partnership. And this partnership's included FP Squared and the National Center for Pavement Preservation. They've been a part of these discussions, which is very good. Some of the benefits that we're seeing is the individual strengths of each other. You know, they do some good stuff, we do some good stuff, and our efforts combined is even better. Operationally, data sharing, analysis, the collection of data, the consistency of the data, I think can be improved by this partnership. And I think we'll have a greater appeal nationally. We're working with NCAT in the south and with Minnesota in the north. It covers quite a bit of a range of extreme climate conditions. The partnership vision is for nationwide impact, and we want to facilitate high-value pavement research that addresses national needs, utilizing full-scale pavement testing facilities in both warm and cold climates on flexible, rigid, and composite pavements. Nationally, we've been kind of acknowledged as and different magazines have been put out looking at, here's the R26 that was done at MnROAD in last summer with a nice article talking about the partnership and where we see we're going with this partnership related to pavement preservation. On this national focus and the direction we're going, Buzz talked a lot about the NCAT facility and the use of test sections on that, along with the Lee Road 159 on the low volume road, but also the high volume that they're developing. Here at MnROAD, we'll be looking at the same thing of utilizing the test facility, past and future research that we're going to do related to pavement preservation, but we're also going to look off-site to develop basically our Lee Road 159 and our US 280 for both high and low volume roadways in similar situations. There's a picture there showing we have a landfill nearby that could be utilized similar to the asphalt quarry that they're utilizing in Alabama. You know, part of it we talked about thin overlays and different efforts that are going on, which some people consider to be pavement preservation. This kind of ties back into what NCAT and Minnesota is doing related to coming up with performance tests related to cracking. You know, as we use economically, we're trying to use lower asphalt contents and more recycled binders to reduce the strain tolerance. The cracking in the surface and near the surface layers is key because most asphalt is produced for rehabilitation, and traditionally mixed criteria have weak relationships with performance and restrict innovation. For example, there's some different efforts that have been going on when they use high recycled mixes. Here's one example showing earlier failures. And using type of a cracking test, performance test, could avoid these types of early failures around the country. So the need for a meaningful cracking test, you know, especially for these thin layers related to pavement performance or pavement preservation, so we need a test and a criteria to relate to performance. We need tests that are practical for both mixed designs, verification, and quality control testing purposes. We need tests to accommodate recycled materials, new and future additives and combinations thereof. So the efforts that we're going to do related to that cracking test and this pavement preservation effort that we're proposing is we're looking at top-down reflective and low-temperature cracking efforts. We're looking at mixtures that are over both concrete and asphalt. We want to look at the range of expected cracking susceptibilities by taking mixes that we expect to crack with a low fracture energy if you use the DCT versus high fracture energy that shouldn't crack. We want to try these things out in the field here, both at our both facilities, and see how they work. We also want to sample the plant for doing a lot of lab testing to kind of confirm the tests that we get from these different types of cracking tests that we do. You can kind of see Minnesota has, at MnROAD, has both concrete that can be overlaid and asphalt, and down at NCAT we'd be mostly looking at the asphalt area. So these are the different types of cracking tests that are out there. Again, Minnesota's been working with the DCT and the SCB, but there's a number of other types of cracking that will be investigated through this cracking experiment that NCAT is proposing. So with that, I'd like to pass it on to Mary to kind of go over some of the benefits of the sponsorship.
Thank you, Ben. Hi, this is Mary Robbins here at NCAT. I'm going to talk to you about some of the benefits and how you can get involved in this partnership. One of the important aspects of these research efforts is that they are designed to meet the needs of our agencies and sponsoring organizations. As a sponsor, you truly have a voice in the design of these experiments. The funding is turnkey, meaning that the funding you provide covers the funding for the full 3-year research cycle and is all-inclusive. Built into the sponsorship fees are the travel funds to be on hand at the time of construction and travel funds for representatives to attend the 6-month sponsor meetings. At the 6-month sponsor meetings, we provide updates on the experiment, and it enables our sponsors a chance to interact with one another and to provide feedback on the study. Additionally, we can provide support necessary to help with technology transfer of important interim findings, so you don't have to wait until the end of the 3-year cycle to get the ball rolling and really start to benefit from your investment. The key outcomes that are expected from these experiments include the development of life-extending benefit curves and the relative condition-improving benefit for the various pavement preservation treatments. And as a result of the cracking group experiment, recommendations are expected for cracking tests for implementation. Another expected outcome is the development of specifications and best practices for the placement of pavement preservation treatments. While the cost structure of these experiments is similar, there are also some differences due to the nature of these experiments. For the PG study, the cost for the first 3 years is $120,000 per year. Because we expect this experiment to continue beyond this initial 3-year period, the funding is front-loaded to support the cost of construction and startup. However, beyond the first 3 years, the cost will drop significantly, leading into year 4 with an estimated cost of $40,000 per year. For the cracking group study, sections will be designed to fail within the 3-year project timeline by building these sections slightly thinner. The cost associated with this experiment is set at $210,000 per year, totaling $630,000 over the 3-year period. Please keep in mind that these costs are all inclusive, including the cost of construction, associated trafficking, as well as funds for sponsor travel during construction and for 6-month sponsor meetings. However, for this partnership between MnROAD and NCAT to exist, we really need the support of those northern states. So you may be asking, how can you get involved? We invite anyone who is interested in the preservation or cracking experiment to contact representatives of the partnership. We would be more than happy to answer any of your questions and, if need be, schedule conference calls or web meetings to engage further discussion within your agency or organization. Our contact information will be listed at the end of this presentation, so please take note. We would love to hear from you. Also, if any of you are attending TRB next week, we will be holding an open house at the Marriott Marquis on Monday, January 12th from 8:30 to 10:30 a.m. in the Delilah Boardroom. I will be on hand to answer any questions that you may have during that time, so if you can, please swing by. For those of you listening from the northern part of the country, the Terra Pavement Conference will be held in conjunction with the MnROAD Workshop on February 11th and 12th at the University of Minnesota. As part of the workshop, MnROAD will discuss findings from their Phase 2 research on the afternoon of the 11th. The Terra Conference will follow up this workshop on the 12th. Buzz Powell will be on hand to give a presentation on this partnership as well as the current NCAT preservation study. So this will be a great opportunity for any of you that are in the area and considering this partnership to hear more about it and to follow up directly with representatives from both MnROAD and NCAT. If you are interested, please keep in mind that we will need someone from your organization to complete our standard letter of commitment to the preservation group and/or cracking group studies, ideally by the end of February. This is a form started by NCAT and completed and signed by someone within your organization with commitment authority stating your intent to financially support one or both of the group experiments in the prescribed amounts. This secures your spot at the table so you may be involved in future discussions about the design of the experiments. The Test Track Conference will be held on March 3rd through the 5th here in Auburn, Alabama. Practical findings from the 2012 research cycle resulting from research on the NCAT pavement test track as well as LeRoad 159 will be presented in a series of technical sessions with a focus on implementation. As part of the conference, we will also tour both facilities. This is another opportunity to see firsthand the types of work being done and some of the implementable findings that are coming out of these efforts. Registration information is available on NCAT's website. This conference also serves as one of the last opportunities for getting those commitment letters in. For state agencies that have a very strong interest in one or both experiments and believe that your agency's participation is viable, please contact Buzz Powell as financial support may be available on a limited basis for travel to the Test Track Conference. Planning for the CG and PG studies will get underway this spring. This is where your voice really matters. As a sponsor, you help direct the design of these experiments, but in order to have a voice in the design, you will need to be a funding partner, and we will need to have your letter of commitment prior to start of these discussions. Once we've come to a consensus on the design of these experiments, construction will begin in the summer of 2015. And in the fall of 2015, we will hold the first 6-month sponsor meeting on site. Sponsor meetings will be held about every 6 months in which updates will be provided and feedback on the direction of the research effort will be sought. These experiments will be conducted as a pooled fund, and final commitment will need to come in the form of sponsorship through this pooled fund. You can find more details at the link at the bottom of your screen.
Thanks, Mary. With that, we'll move into the question and answer session. If you do have questions, you can type them into the question module on the control panel to your right. And the first question is, what is the anticipated timeline for results of the two partnership research efforts? Buzz, do you want to handle that one?
Yeah, I can handle that one. Well, results in these types of efforts typically roll out in 3 phases. And we always learn a lot in our preparation work, but we learn a tremendous amount in actual construction and placement. So results from the construction and placement, and for short-term performance, immediately after truck traffic starts, that information will be available immediately. And then we kind of go into a midterm rollout and a long-term rollout. So the longest term information is the life extending benefit curves that come out of this. We have to actually return these sections to pretreatment condition in order to fully build those curves. So the more time passes, the more we learn, but we'll roll out what we can at the 6-month sponsor meetings and do it as quickly as possible, because implementation is the overall goal.
And the next question coming in is, how much total funding you will request for pooled fund and how long? Buzz, I guess we'll kick that one back to you again.
Well, I think we addressed that. I don't know when that came in, but I think we addressed that in Mary's previous slide. So the first 3 years, the construction and the setup and the first 3 years of measurements for the preservation group, that cost is $120,000 a year for 3 years, so a total of $360,000. Our expectation, because of the long-term performance aspect of it, is that it'll go 4+ years, potentially significantly past year 4, and our estimate for the cost then it will drop down to something in the neighborhood of $40,000 a year. Probably what we'll do is do that through a second pool fund, and a pool fund that would likely be managed by MnROAD. This one will be managed by Alabama DOT for NCAT, and then the next one would probably go up to MnROAD. The cracking group experiment, as Mary said, is $210,000 a year for 3 years. Obviously, there's a significant cost of construction, hauling material, everything from hauling materials to instrumentation to data collection to reporting. It's all included in that total, and it's $630,000, $210,000 a year.
Thanks, Buzz.
May I add one thing, is that the research that has been oral can be done either for the pavement preservation or the cracking, so it could be one or the other. There's options for states.
Yeah, we're really talking about 2 different efforts that are very complementary and related, but states can commit to one or the other or both.
Okay, the next question is, it is the thinking the states will use SP&R funding for funding participation.
The pool fund is approved for 100% SP&R funds.
And how many cells does MnDOT and NCAT plan to build for the cracking study?
Ben, you want to handle that one, or would you like for me to do it down here first?
I can start out. The cracking study, again, it's very important to Minnesota because we've been looking at it related to low temperature cracking or thermal cracks. But we see that this type of test might be beneficial for all type of cracking. So one of our major emphasis is related to verifying the different models that we've developed for this. And so a major effort will be put towards that. I guess I don't exactly know how many test sections, and it depends on the different types of funding that we develop here at MnROAD. That's going to be separately from outside of this to develop that cracking test here in Minnesota. But we can utilize the old westbound concrete to look at different types of overlays with that reflective cracking, along with a number of our test sections related to reflective cracking on asphalt. So we're still in the process of developing that, but that's going to be one of our key areas that we'll be looking at.
Well, and to answer the question from the NCAT perspective, we're going to be limited in the number of sections that we build based on the number of states that participate. Kind of conceptually, what we have imagined is up to 8 different test sections with a focus on near surface performance, because that's what we're doing. I think Ben mentioned that most of what we're doing is milling and inlaying and overlays, and we would like for the surface mixes that we study to vary from virgin mixes with conventional polymer to high polymer, and then have increasing levels of recycled and reclaimed materials, including ground tire rubber. So the more sections we have, the better the scope of the experiment will be, because we really want to challenge these laboratory tests with diverse materials with a broad range of expected cracking performance, so that we can identify the test or tests of the array of tests that we'll look at, which we've got. It's a long list. It's not limited to what we showed in the slide in the webinar. And we, the more sections we have, the more comprehensive the study will be, and the more meaningful the outcome.
Okay, thanks, Buzz. And the next several questions are, will this presentation be posted somewhere? Yes, we did record the webinar, and we will send out an email with that link, and we'll probably also post the link on our Facebook page. That's the NCAT Facebook page. For the US 280 project, how long will the various sections be, and will they be constructed in both lanes? Buzz?
The sections on 280 are set up to be 1/10 of a mile in length, so they'll be significantly longer than the 100-foot sections that we have on Lee Road 159. We will only do, we've got both lanes on 159. We're only going to do the truck lane on US 280, so it's only going to be the outside lane. We'll have to maintain traffic with traffic control out on 280. It's not like 159. It's a very busy road, and it'll have its own unique set of challenges, but we have identified the truck lane, the one with the heaviest and most abusive traffic, as the lane that we want to treat in this experiment.
Okay, the next question is, how are the funds for the PG-15 and cracking group studies distributed between MnROAD and NCAT?
Well, that's a really good question, and Ben, I guess I'll handle that one. The way this is working, at least in this initial 3 years, is that this is being done under the pool fund for the NCAT pavement test track, which is managed by Alabama DOT. The URL for that was shown on Mary's timeline slide, and the funding is essentially set up so that primarily the southeastern states, the warmer climate states that commit to the experiment, that have committed to the experiment in the past, that funding will come to NCAT for the test sections, to fund the test sections that we do here on US 280, and to continue 159, and to continue the track. And the business plan for this is set up so that then, as the northern states come on board, which is why we stress that we really need participation from the northern states in order to make this happen, because we do believe it's a very serious national need, as Mark mentioned. Then when those states come on board, then those funds will go up to MnROAD for the execution of their experiments or for the construction of their test sections, essentially as a subcontractor for NCAT. And then when we go into just the long-term monitoring phase, which will be year 4 through maybe year 10 or 12 or 15, however long these test sections need to play out, that'll probably be done through a pool fund that'll be hosted by Minnesota DOT.
And I guess adding a little bit to that, it was advantageous for us to utilize the NCAT pooled fund because it was already established. We felt that was the quickest way to expedite our efforts. The pavement preservation is the focus there, where really any extra money that we can kind of pull into that pooled fund that allows us, both MnROAD and NCAT, to develop these test sections both in the north and the south, the way I see it, and to look at pavement preservation. The cracking side of it is kind of a benefit for us in Minnesota, because we're looking at the same thing, coming up with a cracking test. NCAT's going to be doing that also down there. And even if we don't share funds related to that, we probably going to be sharing a lot of expertise and a lot of findings that we find between each other. And we hope that their research will include a lot of our efforts, and it'll be beneficial for both of us. But right now it's mostly related to the pavement preservation He's going to help develop test section in Minnesota, help monitor those test sections, and kind of get that northern aspect along with their southern aspect of their pavement preservation efforts. MnROAD will be kind of looking at some other ways for funding research for our next phase 3, which will be on our test track and which will also include pavement preservation. But our funding will be kind of separate that aspect until maybe 2018, and then we can kind of go from there. But in the future, there may be some way of combining those. But again, we're working on this partnership. We feel it's good for the nation to work together on these type of topics.
Okay, the next question is, does the treatment type change after the initial 3-year into the 4th year? Mary's going to handle that one.
Hi. So with the pavement preservation experiment, what we're looking at is for those sections to return to pretreatment condition. And so we expect that those sections will need to be continued to be evaluated and to be monitored into the 4th year and maybe into the 5th year. And so we'll continue to monitor those sections until they have returned to pretreatment condition. If any of those sections have reached pretreatment condition, that's when we will need to make a decision on whether we want to look at different treatments, and that's when we'll come back to the sponsors and have them help us make that decision. Buzz, I don't know if you have anything to add to that.
No, I think that's a good answer, Mary, and I think we're out of time with our slot, so we probably should hand off to Jason to close things out. Okay,
we'd like to thank everybody for joining us for this webinar, and again, just to recap, we will be posting the video up on the NCAT website. Thanks and have a good day.
Hey, Jason.
Mm-hmm.
If you go to the next slide, I think there's one more slide.
So just as a reminder, for any of those that will be at Tier B, you can come meet with me on January 12th from 8:30 to 10:30 at the Marriott Marquis in the Delilah boardroom. I'll be happy to answer any of your questions that you might have. I know we weren't able to get to all the questions that were out there today. So if you're able to swing by, I'll be happy to discuss with you. And you can submit any other questions to Buzz Powell or Ben Worrell, or you can also submit them to Jason Nelson. So we'll get back to you as soon as we can on those. Thank you so much.